Okay, now I'm going to show how to set up a reaction for the reduction of nitro group to amine. There are lots of ways to do this reduction. So very common way people do the nitro group reduction to amine is like tin plus ACl, like SN plus ACl. Suppose if you have a nitro group, like whatever the position doesn't matter, tin plus ACl, um, as a solvent you can use ethanol and heat or reflux, then you will get nitro group converted to NH2. So these kind of reactions, um, people also use stannous chloride and in ethanol and heat. Uh, in some cases, for bigger, larger molecule with many aromatic ring, people also can use chloroform and tin plus ACl, but that is not like very common. The problem is the tin compound or stannous or stannic compounds are like carcinogenic. So nowadays people are avoiding these kind of chemicals. That is number one. So carcinogenic, like it can produce cancer. And second, like this kind of reaction workup is too much tricky and too much problematic, because tin plus ACl or stannous chloride, this workup during the extraction you will get like some white cloudy things or materials which can be difficult to get separation, like those are not solid, not liquid, so the middle of things. Hey Matt, what is it called?
What?
Something material, like not solid, not liquid.
Not liquid. A gas?
No, not gas, like
Amorphous?
viscous materials, like something like you are doing extraction in the separatory funnel, so that is not solid and that is not also liquid, but staying in the middle of two liquid.
Yeah, is it an amorphous solid? Where you it's solid
Yeah,
like you can
maybe
use it
like not quietly solid. Anyway, so people also do nitration reduction like to amine by using iron turning in acetic acid and heat it up. So that will also give you the amine. Or sometimes ferrous chloride also help in presence of CH3COOH like acetic acid to give amine. So that is nowadays people are practicing this way, not the tin or tin component reaction. So because this workup is easier, lot more easier than the tin component. But now sometimes in specific cases you can also do the nitro to amine reduction by using zinc metal, activated zinc in acetic acid. So especially if you have any aliphatic type position where you have the nitro group here, suppose you have aromatic group here, so this nitro can be converted to amine by using so I'm basically making this nitro to this amine aromatic ring. So tertiary carbon amine by using activated zinc in acetic acid, and room temperature 12 hours done. And reaction workup, I'll show how to do the workup. So this is the normally those are very common technique for nitroamine, like tin plus ACl. If you don't have those options are not working, then you can go for the tin plus ACl or like stannous chloride ethanol heat. But if you reaction work with the like iron turning acetic acid or like ferrous chloride in acetic acid, then you can easily make amine. But for this specific reaction, it is very nicely work nitro to amine. So when the nitro group is not in the aromatic ring, is in the aliphatic, so you can use activated zinc, ethanol, room temperature, stir it at 12 like room temperature for 12 hours. You will get the completion of this nitro to amine by this reduction process. These two processes basically the like almost same. Those metals are reacting with the acid to form like hydrogen in situ. That hydrogen will reduce this nitro group. And like if you use ferrous chloride, it will be converting to ferric chloride, so it will be oxidized to ferric. Like it convert to ferric, so ultimately it will produce amine. And for the zinc, it will produce zinc acetate or something. Ultimately it will produce hydrogen and it will reduce the nitro to amine. So now I'm going to set up that reaction. So I already have the activated zinc. I see my previous video how to do activation of the zinc metal. So here is the zinc metal. I activated it, so I'm going to use it for my this reduction reaction. So let's see how we are going to set up this reaction. Okay, here is our compound, nitro compound, dried and kept it in a oven dry flask. So now I'm going to use the acetic acid, and for the procedure, if you need to know like how much acetic acid you have to use, I can give the reply if you ask me the question in my links, or like it should be like 0.1 molar final concentration. So here I'm going to use like 1.63 gram starting material, so I'm going to use 65 milliliter of the acetic acid. So that's how it will work. So okay, here I'm taking the acetic acid, 65 milliliter. Like 60 ml, so first add the 6 ml, and with the tube I put the gas so that the blood pressure can go through the gas line. So I need to take 5 more milliliter. Acetic acid. reaction flask. Try to add all the compound by swirling like this. Whatever, it may not dissolve completely, it's fine as long as, so you can start heat stirring. So let it dissolve those compounds by stirring. So it will dissolve them. I will start adding the activated zinc. So it will be 6 equivalent of zinc times 4 times. That means 24 equivalent of the 24 equivalent of the starting material millimole. So whatever the amount you are using as a starting material, so just take 24 equivalent zinc, but don't add all zinc together. Divide the amount by 4, and every half an hour add that 1/4 of that. And once your 4 times addition is done, then leave this reaction at room temperature for 12 hours, and next day just filter the reaction system, and then wash out with the DCM and remove the zinc, and then do the rotoweb, remove the acetic acid, and then so now I'm going to use the zinc, add zinc here to start the reaction, first portion of the zinc. So here is a 2.52 gram of the zinc, my first portion for the first reaction. So I'm going to use this as soon as possible because this zinc was activated and it shouldn't be air exposed for a long time. So just add it in your reaction quickly. Now I'm starting adding the zinc, activated zinc quickly while it is under gas. So it is under gas. I just open quickly and add the zinc.
Oh my god. Okay, there you go.
And quickly and give some quick degas and then put some gas. That's it. So I will invert this power sector now.
Ta-da!
And it will continue, and right after 30 minutes I will add one more portion of the same amount, and then again 30 minutes I will add one more portion, and finally after more 30 minutes I'll add one more portion of that zinc, and then I'll leave the reaction for 12 hours to go forward. So this is the reaction after 12 hours. So I'm going to now stop this reaction first, take this out because it was under gas. So activated zinc. So you see, now I'm going to filter it. And to do the filtration, I need a aluminum flask and the like funnel. So I'm going to use one of this funnel and the aluminum flask, one of this aluminum flask. So after filtration, I will remove the solvent, and then I will work up because it is acetic acid. So after removal of the solvent, maybe I will add aqueous sodium bicarbonate solution to remove the acetic acid, and my compound will be like amine. So in base form, like in basic condition, amine will be free and it will be easy to extract. And after extraction, I will remove the solvent and I will get the crude amount. Normally, this reaction doesn't need to don't require the column to purify, so I can move on in the next step without purification because it is a very clean reaction, clean conversion also, like 100% conversion. So yep, this is the reaction. So hopefully it will help you to understand the activated zinc reduction of nitro compound to amine. If you have any question, you can ask me, I can answer. Bye now.